because let's write it variance and standard deviation. Okay. So for doing mean deviation, what we were doing was you were doing sigma xi minus x bar, and then you were taking a mod, right? This is the sum of all deviations. Yeah. You divide it by n, and when you divide it by n, what do you get? Mean deviation, average of all deviations, right? So the thing is, see, for doing this mod function, let's say you have a large amount of numbers. Go back to how you were doing it actually. Suppose there was a list. What you were doing is you were so 1 2 3 4 5 6 7 7, let's say 7 है, ठीक है? इसका mean is of course how much? Mean is 4, no? Mean median doesn't matter. It is 4, no? So while you're doing sigma xi minus x bar, you are taking care of 1 minus 4 when you're doing 4 minus 1. And when you're on the left side, you're taking care that you are mean minus that number. Actually, if you break down this, what is this mod actually? You're doing mean minus that number, and when you overshoot this side, when you come, you're doing that number minus mean, right? This is a typical case of decision fatigue. You're taking a decision fatigue, means you have to check idhar ho udhar ho, right? If you put it, so this is a decision fatigue for human also, right? Correct? If you put it in a computer will also do the same thing. It will always do that loop twice. If you have a large millions of numbers, your time will be get doubled, time of calculation. उसके लिए क्या करना है? Simply do some operation. You're doing this operation to get a positive result, right? So what you do is you simply do square. No, mod square, and very interesting question. Mod square and just square, both are same thing. It doesn't matter, because whether it's negative or positive, the mod, if you do a mod, the number is positive, and then you square it, and say the second case where just any number, square it, so still positive, right? So this is called, अब ये जो number quantity है ना, इसको क्या बोलते हैं? Standard deviation. Sorry, variance. This is called variance. Okay, sigma of xi minus x bar square divided by n. ठीक? And standard deviation is nothing but square root of variance. Okay, so standard deviation SD is square root of variance. Understood? Write this, write that. One more thing, variance is denoted by sigma square, ऐसा ये symbol square है, and standard deviation is just ये, ठीक है? So standard deviation is the thing sigma, and variance is sigma square. Standard deviation is square root of variance. There is one small, लिख लिया ना ये? देखो एक small चीज है यहाँ पे. If you open this, this is a whole square, no? So you'll sigma of ये कितना है? xi square plus square n minus 2x xi x bar by n. ठीक है? Now इधर से देखो, this is summation, right? So you can separate this summation, no? So you can write this as sigma of xi square by n plus sigma of x bar square by n -2 सिग्मा ऑफ, और बेसिकली सिग्मा ऑफ 2, सिग्मा ऑफ, ठीक है, सिग्मा ऑफ 2 xi x bar by n. Understood? See, now see, very important question. For different I values, ये xi is different, but x bar is same, no? X bar is same. Yeah. And you also remember we did a question like, if there was some xi minus 2 ka bar, so you were doing x1 minus 2 plus x2 minus 2. This 2 is same, no? Every time. If a number is constant, it is same every time, right? इसमें constant क्या है? It is always same. This is a constant, right? So ये same है ना, ये this is same, right? You are adding it over and over. If you are adding it over and over, this will come out. And how many times you are adding? So you are adding. So you इसका आंसर कितना आएगा? n times x bar square. Right? Understood? If you don't understand, I'll explain. Sigma of xi square, जैसे मान लो इसका वैल्यू है 4, तो सिग्मा ऑफ 4 कितना है, कितनी बार है ये? 4 प्लस 4 प्लस 4 कितनी बार? n टाइम्स है, तो 4n आएगा ऊपर, नीचे n है, कट जाएगा तो सिर्फ 4 बचेगा। तो ये जो कांस्टेंट जो भी है वो बाहर निकल सकता है। ओके, अब बाहर निकलेगा, तो इसका वैल्यू कितना होगा? i नहीं होगा, इसका वैल्यू देखो, ये जो ऊपर है ये n इंटू एक्स बार स्क्वायर है। नहीं समझ में आएगा? एक्स बार स्क्वायर होगा ना, ये जो ऊपर है, दिस इज हाउ मेनी टाइम्स इट इज एक्स बार स्क्वायर, ये कितनी बार रिपीट है? n टाइम्स। सो इसका जो आंसर आएगा ये मिटा के आई विल जस्ट राइट n इंटू एक्स बार स्क्वायर। यस और नो? n गया, ठीक। अच्छा एक चीज और देखो, ये समझ में आया? अभी इधर देखो, इसमें से इन दोनों में ये xi और x बार है, ये बाहर, ये कॉमन, ये कांस्टेंट है, बाहर निकाल दो, 2 बाहर निकाल दो, तो बाहर आएगा, कि बाहर क्या आएगा? 2 इंटू एक्स बार बाहर आएगा, और अंदर देखो क्या है? सिग्मा xi by n. What is this? That's mean, and mean is called x bar. So it's nothing but, this is nothing but x bar. This is very important to understand. यहाँ पे 2 and x bar बाहर निकाला, अंदर है sigma xi by n. Sigma xi by n is what? Mean. Yes or no? If it is mean, sigma xi, so this quantity is x bar only, right? So you have 2 x bar, 2 x bar square. Yes or no? Sorry, छोड़ो, 2 x bar square, and this is just x bar square. 1 x bar square minus 2 x bar square, it is minus 1 x bar square. Yes or no? हाँ, समझ में आया? मीन एक क्वांटिटी होती है, उसका स्क्वायर करना है। So therefore the variance is also equal to sigma xi square by n minus x bar का स्क्वायर। यहाँ पे देखो ये इंपॉर्टेंट है कि कहाँ पे बार लगा है, कहाँ पे स्क्वायर है। ये सिग्मा ऑफ xi स्क्वायर, दिस इज नॉट सिग्मा xi एंड देन स्क्वायर, इट इज इंडिविजुअली स्क्वायर देम एंड देन ऐड देम, डिवाइड बाय n माइनस टेक द मीन स्क्वायर। अंडरस्टूड? अंडरस्टूड नो? ठीक है, थैंक यू।